Welcome to lesson 5, where we are going to discuss negative exponents with powers of 10. We're going to be looking to see what happens when exponents are negative. So the criteria for this lesson is to be able to use the exponent rules that we've discussed in the previous videos, but now with negative exponents. And then we want to be able to know what it means if 10 is raised to a negative power. We start with a number talk. You are given 3 equations. I want you to try and solve them mentally first. So go ahead and pause the video and then we'll talk about patterns that we see in a moment. So in the first one that they give you, they start with 10 over 1. And you are then supposed to determine that exponent. And the base is 10, so we know that 10 times 10 is equal to 100. So we can say that the exponent is 2. In the next one, they give you 10 to the first, and they give you a denominator of 100. And so that must mean that we have to divide 100 by 10 in order to get 10 to equal 10 to the first. In the next one, we have 10 to the power of 0, which in our previous videos, we discovered anything to the power of 0 is going to be equal to 1. So that must mean that 100 over 100 has to be true for this statement. So now if you start to notice patterns, you notice all of the numerators are 100 and all of the denominators increase the factors of 10 that they have in there. So essentially those denominators are getting bigger, but really that entire value of the fraction is getting smaller as we change the exponent, right? And then you notice the exponent is decreasing by 1 each time. So just by looking at that pattern, we might think that 100 over 1,000 is going to have a negative exponent. And in the next 2 activities, we're going to start to explore these negative exponents and talk about why this is true. So we start with a table with negative exponents, and it looks something like this. And you're going to complete 1 row at a time to see the patterns most clearly. So you're going to go through all of the using exponents row, all of the decimal row, and then all of the fraction row. After you complete those 3 rows, go through the questions that are listed 1 to 6, see if you can answer all of those, and then we'll discuss the rest together. So pause your video at this time and give it a try. Okay, let's look through some patterns. So we're going to go through using the exponent row first. So we see, similar to the warm-up, 10 to the third, 10 squared, 10 to the first. So we might guess that the exponent is decreasing by 1 each time. And we end up all the way to 10 to the negative third. Then we go into the decimal row. Now, you also might notice at the top, you have the arrows showing the times 10. So you might have used that to kind of help you go from one of the columns to the next. Maybe you said, oh, if I know I'm multiplying by 10 going this way, then I'm maybe dividing going the opposite way. And so you'll see here that these are all listed. We have 100, 10, 1/10, 1,000 that are filled in. And then you should be able to just relate from the decimal to the fraction simply by just rewriting them. So we have 1,000 over 1, 10 over 1, 1/10, 100. So now that we've done that component, as we move toward the left, each number is being multiplied by 10, as I already stated. But what is happening, what is the multiplier when you move left to right? So I said there's this relationship. We know that if we're multiplying from right to left, you might have seen it as division, but they're asking for the multiplier. So to go from 1,000 to 100, we know we would have to multiply by 1/10, which is essentially the same thing as dividing by 10, but we're looking for the multiplier. Going from 100 to 10, 1/10, going from 10 to 1, multiply by 1/10, and you're going to continue doing that all the way throughout. Okay, so you started to notice some relationships there. Let's look at how each of these multipliers affect the placement of the decimal. So we're going to look just at this row right here. Well, notice as we start at 1,000, and then we go to 100, and then we go to 10, and we're getting smaller, that decimal place is actually moving 1 place value to the left because everything's in powers of 10 right now that we're working with, right? So I divide by 10, or I multiply by a tenth, and that decimal place moves one space to the left to make that number smaller. But if we started at the opposite end, let's say we started with 1,000 and we multiplied by 10, that decimal place now moves once to the right because we're getting bigger. Look at the value of 1. If we go from 1 to 10 and we multiply by 10, the decimal place moves 1 to the right. Using the patterns we found in the table, let's write 10 to the negative 7th as a fraction. So just kind of going back here, if you look at 10 to the negative 3rd, that's telling us how many times to multiply 1/10 together. So 1/10 times 1/10 times 1/10, that gives us 1 over 1,000. So we have to make sure we understand that that's what that negative exponent represents. It's not the number of zeros that are in the decimal or the fraction that we're writing. So we would write this as 1 over 10 million. If we were to write 10 to the negative 5th as a decimal, it would look like this. If we were to write the following fraction using a single exponent, it's being multiplied by one more tenth than 10 to the negative 7th was. So it's 10 to the negative 8th. So if you look at these patterns, let's determine what is 10 to the negative n as a fraction. And we would say that it's 1 over 10 to the positive n. So anytime we're looking at a negative exponent, we're really multiplying by 1 over 10. So if multiplying by 10 increases the exponent, what does multiplying by 1/10 do? It decreases the exponent. Negative exponents can be thought of as repeated multiplication by 1/10. Positive exponents can be thought of as repeated multiplication by 10. And again, 10 to the negative n, we'll say is 1 over 10 to the n. So just a final example before we move to the next activity. So you could kind of piece this together. 10 to the negative 3rd, we're multiplying by a tenth 3 times, which is the same as saying 1 over 10 to the 3rd. So again, 10 to the negative n is equivalent to 1 over 10 to the positive n. So revisiting that criteria, we should be able to use the exponent rules with negative exponents and then know what it means if 10 is raised to a negative power. So right now we've really kind of hit that second criteria pretty hard, and we'll dive deeper into that first criteria in this last activity. Okay, so let's follow those rules that we just talked about in the criteria. You're going to match the expressions that describe repeated multiplication in the same way, and then you're going to answer the follow-up questions. So you're going to work through numbers 1, 2, and 3, and then answer each of the part Bs, and we will come back together after you pause your video and try this on your own. Okay, so I'm going to go ahead and show you what you should have matched together for each of these, and then we're going to dive a little bit deeper into some components and what they mean and how they relate to those multiplication, division, rules, power to a power, all that stuff that we discussed in previous videos. Moving into part B, you'll see that we're looking at 10 to the negative 2nd over 10 to the negative 5th, which is, again, division. And we talked about those rules being subtracting the exponents, which is why we would get 10 to the 3rd. Now here's the why behind it. We're really doing -2 minus -5, which is the same as adding 5. So that's why we're coming up with 10 to the 3rd. If you decided to list out the factors, you would have seen it as a tenth times a tenth over a tenth times a tenth times a tenth times a tenth times a tenth. And if you continue through that process and rewriting it, you would write that as 1 over 10 squared divided by 1 over 10 to the 5th. And then, using division rules, you're really multiplying by that reciprocal. So it can be written as 10 to the 5th over 10 squared, which is equal to 10 to the 3rd. So again, 2 different ways of just kind of working your way through it. In matching number 3, okay, so we had power to a power. We looked at quotients. Now we're looking at multiplying again. So this takes us back to those rules of where we would be adding the exponents together. And so in part B, we should have gotten 10 to the negative 1. And so here's the y to it. Again, adding the -4 and the 3 together. If you listed this out, you would have had the 1/10 4 times, the 10 3 times being multiplied. You could rewrite that as 10 to the 3rd over 10 to the 4th. and then that equaling 1/10, which is 10 to the negative first. Think back to elementary school, you wrote things like this: 4 times 100 plus 5 times 10 plus 6 times 1 is equal to 456. You could start to think about these things by using exponents. So changing it, instead of saying 100 to 10 squared, instead of 10, 10 to the first, and instead of 1, 10 to the power of 0. So let's try a different one. If we had 2,796, how would we write this with a sum with powers of 10? So we would think about each of the place values that the numbers are in. So 2 times 10 to the third would take care of the thousands place. 7 times 10 squared would take care of the hundreds. 9 times 10 to the first would take care of the tens. And then 6 times 10 to the power of 0 would take care of the ones place. In a similar way, we would think about small numbers using negative exponents. So again, 1/10 is 10 to the negative first, etc. So if we were to look at writing a decimal as a sum with powers of 10, it would look something like this. 2 times 10 to the negative first, which is going to take care of the tenths place. 7 times 10 to the negative second is going to take care of the hundredths place. 9 times 10 to the negative third is the hundreds place. And then 6 times 10 to the negative fourth is the thousands place. So in a very similar fashion, just using negative exponents. So think about the meaning of exponents. How are these two exponents related? 10 to the third and then 10 to the negative third. Exponents tell us to repeatedly multiply by a base. Whether the base is 10 or a tenth, the structure of repeated multiplication is the same. 10 to the third is multiplication by 10 repeated 3 times, and 10 to the negative third is multiplication by a tenth repeated 3 times. Who would actually need to work with such large numbers or small numbers? Astronomers would probably be working with large numbers, and people like biologists, physicists, engineers, they would be working with smaller numbers. You could read through your lesson summary, but you are successful if you feel that you can use the exponent rules with negative exponents and then know what it means if 10 is raised to a negative power.